Welcome. My name is Abel Sanchez. In this lesson, we're going to bring it all together. We're going to use all those callbacks we have covered. We're going to look at map and reduce. We're going to look at some filtering. We're going to look at for each and some sorting potentially. Let's go ahead and move over to the code. We're going to be working with data we've scraped off the web. This is public data from the MIT course catalog. And as you can see, this is some pretty raw information here. It's simply HTML that has been scraped, and it has all of the tags and styles and everything else that would be used for displaying course information on a web page. And so it has no structure. And so one of the things that we're going to do is we're going to manipulate it, we're going to work with it, we're going to dig into it, and using the callback functions, we're going to pull out, extract, format, and create some analytics. At the end, we're going to use these analytics to pass it on to a graphing package and generate some visuals. So let's go ahead and move over to the code. The very first thing that we do, and let me make one last point. We move to the top of this file. As you can see, that giant string of tags is all assigned to one variable called MIT courses. And so the very first thing that we're going to do is that we're going to assign that text onto the HTML document. When we do that, this becomes part of the document, and we can leverage that to use the structure of the document to provide some initial filtering. So the very first thing that we're going to do is we're going to pull out the H3 tags. It happens to be the case that with this data, all of the course titles are enclosed in H3 tags. So that's pretty useful. We noted that, and we use the get element by tag name to be able to pull out all of those course titles. So that gives us a node list at that point. However, the node list has a little bit of too much HTML structure to it, and we want to move to a more traditional plain array. So that's what we do in this next step. We use prototype.slice on the array function to be able to pull out a clean array. We use then that array to be able to get the titles. We use a map function where we pull out the inner text of each of those nodes that we have within the list. Now at this point we have a traditional array with a bunch of titles that correspond to all of the titles for every single class within that file that we looked at. Now the next step that we do is those titles may have information that we don't want. It might have numbers. Well, in fact, all of these have numbers, and that's how they are numbered at MIT. It might have punctuation. It might have some other things that we don't want. And so we're using another mapping function on the titles array that uses a regular expression. And if you haven't seen regular expressions, you can go online and read more about them. They match patterns, and in this case, we're using that pattern to be able to identify punctuation and numbers and to filter them out. In this case, we assign the resulting set of words onto a words array. Now the next step that we take after that is that we want to flatten this to a simple array that simply has words within it. We'll then use that array to be able to produce some analytics. So that's what we do next. We use a reduce function on the words array, and we pass as an initial value an empty array, and as we loop through it, we're adding all of the words onto this new array. So we have a nice flat array of words at this point. And the last step that we take is we use another reduce function on the words flat array to be able to count the occurrence of every word. You can imagine that given that these are course titles, there are certain words that will appear frequently. Say, for example, introduction or science or engineering, given that we are a science and engineering school. So we use the reduce function to be able to loop through all of the items in this flat array of words and be able to count the occurrence of every word. Here on line 40, we simply check to see if that word is already part of the words that we're doing analytics on, and if it is, we simply increase the counter. We use as an initial condition this object, and as you can tell here, we carry it forward, and at every new call of the reduce function, we check to see if this word exists within the object as a property. If it exists, we increase the property by 1. If it doesn't increase, we set the property with a value of 1. And so that's how we generate a count of all the words. And then the last thing that we do is we graph, and we're doing some work behind the scenes in order to generate a force graph. So let me go ahead and show you that now. I'm going to go ahead and go to the browser, and I'm going to enter. And as you can see there, we've generated some bubbles, and each of those bubbles correspond to the frequency of words from that analytics work that we just did. So if I move my mouse over them, you can see there that design is one that appears quite a bit. Engineering, as you might expect as well. Environmental is another one. We have dynamics, analysis, modeling, structural, civil, mechanics, and so on. Now, as an assignment for you, I'm going to ask you to provide even better filtering, because as I'll show you in a second, you can see that we also get groupings of things that really provide no value, things like and, for, and so if you go back, in individual letters as well. So if you go back to the code, you can certainly see an opportunity to provide a much better set of words to this point, so that the analytics that we perform, the word counting that we perform, has more signal and less noise. Now, this file that we're working with is a reduce file. In case this one says all here, but this is because I was modifying it simply for illustration purposes. This is actually the one file, and if you change it over to the all file, you will be able to load all of the courses from MIT. This initial file has only a few hundred courses. The full file has thousands of courses. So if you load that one up, I have that in a separate page here, you'll be able to see a storm of bubbles pretty soon, and it takes a while, and all of those bubbles fighting each other to be able to organize themselves onto the screen. Eventually they'll settle down, and you'll be able to see some patterns. There it's starting to you can see here advanced, you can see signal, you can see collaborative, you can see healthcare, you can see strategy, you can see stochastic, and you get the idea. Just tons of information. So as an assignment for yourselves, go ahead and set up better filtering with the small file, the one that says no one. And once you have a good technique, you can expand onto the larger file. I'll provide both of those for you. That has everything within the catalog. You could also try to extract not just the course title, but you could also dig into the description as well. You'd have to figure out how to pull that out. But that's sort of the fun part of data science exercises, that hunt and and discovery when it comes to extracting information. So with that, I'll wish you happy coding, good luck, and say goodbye.